I want to thank everyone who's on to join us. As we kind of recap this, I'm going to turn it over. We've got our grant partners, Jason Cooper from Southwest Regional Planning Commission and Mindy Goodrum from FB Environmental, and Tim Mosier, one of the homeowners involved in the grant. So Jason, I'll turn it over to you to start us off, and thank you for recording and for everyone to be here.
Great. Thanks so much, Kelly. My name is Jason Cooper. I work with the Southwest Region Planning Commission based in Keene. We are one of 9 regional planning commissions within the state, and we provide technical assistance to 33 communities within Southwest New Hampshire. We have served as the grantee for this project and have worked closely with the New Hampshire Department of Environmental Services, Spofford Lake Association, and our project consultant, Forest Bell Environmental, throughout the duration of the grant. And believe it or not, SWRPC has been collaborating with DES, SLA, and FBE for nearly 8 years now, spanning 3 different grants with Spofford Lake. In early 2017, work began on developing Spofford Lake's watershed management plan, which utilized EPA Section 604B funds, which were administered by New Hampshire Department of Environmental Services. After the plan's completion in 2018, an EPA Section 319 implementation grant was awarded, which funded the improvement of several locations within the watershed, including Camp Spofford, as well as 5 residential sites. Now we are wrapping up our second 319 implementation grant, which has allowed for the reconstruction of the Spofford Lake boat launch parking area, improvements to 3 residential properties, and soon to be additional work on a culvert in need of improvement. I'm really glad that SWRPC has been able to work so closely with SLA over the years to help protect such an important resource for all of us, and I look forward to future collaboration. At this time, I'd like to welcome Mindy Goodrum from Forest Bell Environmental to share more about the implementation work completed during this grant cycle. And Mindy, you should be able to share your screen, but let me know if there are any hiccups.
Okay, great. Thanks so much, Jason, and thanks everyone for joining tonight. I've got some slides to share with some photos of the work that's been completed, and I'll kind of talk you through what we've been up to for this phase of the grant. So let's see if I can share my PowerPoint with you all. And then I start the presentation. Can you guys see the side with the notes, or do you see the full screen?
We're seeing the notes.
We see the notes, yeah.
Sorry, this always happens. Let me try to swap the screen. Okay. How about now?
Much better.
You're good.
Great. Let's see if this works. Okay. Did the slide transition okay for you guys? Perfect. Okay, here we go. So Jason already kind of went over some of this background stuff, so I can breeze through it a little bit. As he mentioned, the work we've been doing recently is funded through Section 19 of the Clean Water Act from the EPA. It helps protect against non-point source pollution in watersheds, which I'll talk about in just a few slides. As Jason also mentioned, this work began with the Spofford Lake Watershed Management Plan, which was completed in 2018 with a lot of the same partners that are working on the current project. Some of the key findings from the Watershed Management Plan are that the high phosphorus load that the lake has been experiencing, half of that has been coming from watershed runoff, which is kind of where the non-point source pollution comes into play, and what has been our big focus to reduce as a part of these implementation grants. The Watershed Management Plan set a goal to reduce 42 pounds of phosphorus loading to the lake. So that would be 42 pounds entering the lake each year that we want to reduce as part of implementation efforts on this plan. And as part of the plan, they identified 16 watershed non-point source sites and 194 medium and high priority shoreline properties that needed to be addressed in order to help meet that phosphorus loading goal. So as I mentioned, one of the big focuses of this project is addressing non-point source pollution. So in contrast to non-point source, point source solution would be an easy source to identify where, you know, there's a factory pumping pollutants into a lake coming right out of a pipe, you know exactly where it's coming from, you know exactly what it is. Non-point source pollution kind of comes from stormwater that washes over different land use types and collects pollutants as it flows into water bodies. It's really hard to identify exactly where some of these pollutant sources are coming from as it spreads over such a wide area. Sometimes individually, these might be small problems, but as the graphic kind of indicates, they all add up to be potentially a larger issue. So non-point source pollution has been the focus of our implementation grant. So reducing stormwater inputs and erosion. So to help filter out pollutants like phosphorus and nitrogen that can help lead to things like algae blooms within the lake. Spofford Lake especially has been threatened by having low dissolved oxygen in the bottom of the lake, which can help contribute to what's called internal phosphorus loading, where phosphorus is released from sediment on the bottom of the lake, and this happens in low oxygen conditions. So we want to limit the phosphorus inputs to the lake surface in order to help prevent algae blooms within the lake. As Jason mentioned, I think he already went through most of these partners that have been working on the project. But in addition to my group, FB Environmental, we've also been working with Horsley Witten Group, who is our subcontracting engineering firm, who helped draft the plans, especially for the boat launch area parking lot part of the project. And they're also helping with the culvert replacement portion that Jason mentioned.
Mindy, I didn't see your slide advance.
Oops, sorry.
Jason, do you see it?
Wrong. You got two
There you
screens.
go.
There
Perfect.
we go. Sorry.
Thank you.
Thanks. Yes, so here's a list of a lot of the partner organizations that have been working on this project. And as mentioned, the goal of the current 319 grant is to address pollutant loads through 3 residential sites, the 1 municipal site at the boat launch parking lot, as well as outreach and education events like this to help raise awareness in the community of what we're doing and what landowners themselves can do to help protect lake water quality on their own properties. In contrast, the phase 1 project involved 10 different sites and ultimately reduced phosphorus loading by an estimated 9.2 pounds of phosphorus, which meets about 22% of the 42-pound goal that we're setting overall. The final phosphorus tallies for the phase 1 project are still waiting on a couple of final projects to be completed. So looking at some of the management practices that have been implemented as part of this project, I thought first I would walk you through some of the general conditions of these practices, and then I'll walk you through the actual sites and show you some photos of them being implemented at the sites. One of the practices that we've been using at the boat launch parking lot in particular is called bioretention. This is what might look like a nice garden area from the outside, is actually a specially engineered area that can help filter out pollutants from stormwater. It helps retain stormwater as well so that it can slow the flows out of the area during a storm. It helps hold the water there for a little longer than it would just flowing through the system without the plants and this special media. As you can see from these graphics, there's a lot of different layers that go into it. From plants to a special planting media. Usually there's some sort of crushed stone layer to help promote drainage. There's some pipes and overflow structures all working together to help contain the stormwater, filter out pollutants like phosphorus and nitrogen, and then eventually discharge the cleaner water into Spofford Lake. Another of the practices that we've used as part of this project are called check dams. These are stone structures typically placed within ditches or swales, and their purpose is to help slow down stormwater flows through those ditches, particularly on like moderate slopes. This will help reduce erosion by slowing down the water. It reduces its ability to erode the ditches as it flows, or things downhill of the ditches. Slowing the water also can promote some level of infiltration as it sits behind each of these dams. It can allow some of that water to sink into the ground, which will help naturally filter out some pollutants as part of that process. It can also help reduce sediment loads to the lake by allowing the sediment to filter out between each of the check dams. Another one of the practices are rubber raisers. These are a method of water diversion typically used on gravel roads or gravel driveways, sometimes along trails as well. Essentially, it's a piece of rubber conveyor belt sandwiched between a couple of pieces of timber. It's angled across the road or driveway to help divert the water into an area where it can be treated instead of eroding roads or driveways. Typically, it would flow into some sort of dry well, which is like a dugout area filled with crushed stone that will help drain that water into the groundwater where it can be filtered before it enters the lake. All right, and now I'm gonna walk through some photos of the sites that we actually addressed as part of this project. The first, which many of you probably recognize, is the Spofford Lake boat launch parking lot. These are some photos prior to the project being conducted, kind of showing the conditions to begin with. We have a lot of impervious surface cover from the parking lot and the adjacent roads, which means the stormwater can kind of pick up velocity and pick up pollutants from the parking lot and the roads where cars are pretty frequently driving, parking, gathering. So there's a lot of potential pollutants associated with a road like this and a parking lot. We already have some existing detention areas. They didn't have any stormwater treatment in them at the time. There were some catch basins in the parking lot that would capture water and let it flow to the lake, but there was no actual treatment of the stormwater. That was just a method to capture and transport water out of the parking lot into the lake. There was also erosion observed at the outlet of that culvert that would take the water from the parking lot and put it in the lake. So we could tell there were some issues with stormwater volume and lack of stormwater treatment at this area. So as mentioned, we enlisted our engineering partners to design some bioretention systems for the parking lot. This is just a small clip of the engineering plans, which you probably can't read very well on your screens, but it just kind of goes to show that there's a lot of pieces that go into these bioretention systems. So we ended up using those two existing depressions to form two different little cells of bioretention. Together, those would be outletted into the existing culvert outlet, which we added some rock protection to closer to the lake, and that's off the screen shown here. The outlined area here in the dashed line is the parking lot area, in case it's hard to locate where we are. We also added a paved swale along the edge of the parking lot to help direct more of the water into the larger bioretention system. Construction can be messy. Here's a few of the in-progress photos. It doesn't always look as nice while it's being constructed, but it's nice to see kind of the progress of what's going on. So on the left here, you have a picture of one of the bioretention systems being dug out before they added in any of those layers of stone or plants, which you can see on the right here, what they've added some of those systems into one of the detention areas. And then this was constructed in the spring of this year. And you can see these photos were taken in September. The grass has come in nicely. When you're facing the lake, this cell here is on the right. So it's the larger one. In the left photo here, the rock area leads to some concrete pavers. This portion of the system helps to settle out the sediment before it gets into the planted area to make it a little easier to clean out and filter out that sediment. Whereas on the left, you see the overflow structure in the middle of the grassed bioretention area. These systems are designed to treat a 1/2 inch of runoff from the surrounding impervious surfaces and are estimated to reduce the phosphorus loading to the lake by an estimated 0.75 pounds of phosphorus per year. And I have another set of photos from the left side of the parking lot. And this is, again, what they looked like just at the end of September, so pretty recently. These have what are called weirs, which are similar to check dams. The timber structures you can see on the left with the rocks, well, you can see in both photos, the timber structures with rocks behind them. This helps to control the flow through the system and again, helps settle out sediment at each of those steps. Moving on to one of our residential sites. This is located on Linfield Lane in the southwestern corner of the lake. These landowners were experiencing high stormwater volume flows and erosion down a drainage channel that flowed water from culverts crossing Route 63. The amount of stormwater was eroding both their drainage channel and their neighbor's property. It was causing concerns for flooding and bringing a lot of sediment into the lake. So the solution we came up with here was to widen the channel and add check dams to help slow the flow and prevent that erosion from occurring. So we lined the channel with some rock and added those check dams to help slow flow. So you can see here a couple of before and after shots of this project, which was completed last fall. The completed photo is from last fall. And here's just another angle of those check dams flowing down the slope. And from what I've heard from these landowners, they've been really happy with the results and have really noticed a difference in the erosion and the stormwater flows on their property and their neighbor's property. Moving on to another of our shoreline properties. This is from Lake Drive, and we have Tim Mosher here from Lake Drive in the northeastern corner of the lake. They also were experiencing high stormwater flows and erosion, this time along the road from steep slopes in the area that just transported a lot of water down their road and into the lake. This road had a couple of existing catch basins to collect the water, but it wasn't really being well directed into the catch basins. So they weren't being necessarily well utilized, even though they had some methods for capturing stormwater. So the solution we came up with here is to install a series of rubber risers to help direct water off the road and into the existing catch basins. And they also installed a new dry well to direct water in an area that didn't have a catch basin but was still experiencing some erosion. So the dry well kind of acts similarly to a catch basin in that it will help collect the water and bring it down into the groundwater. So here's a before and after shot of one of the upper rubber risers. And I've got another one of one of the lower rubber risers. You can see kind of some of the erosion here on the right that was occurring down this path, which hopefully has been addressed now. And these folks were lucky enough to have some contractors at hand on the road, and they were able to install this project themselves. And here's a few photos of the group at work. And Tim, I don't know if you have anything you want to add about how this project went or what you learned from it.
No, I mean, I think it was a real opportunity for us to come together. There was about 10 different homeowners that were involved in the project, And as you mentioned, I think we had, prior to initiating the project, we had a couple years of pretty significant runoff, a lot of property damage, a lot of erosion that we saw causing. So we had a lot of motivated people that wanted to do something. And I think one of the nice things is that we knew we wanted to do something, we just weren't sure what we wanted to do. And this grant really gave an opportunity to catalyze a very enthusiastic group and have us come together. And I think a couple, things that really were good take-home points, which you mentioned, was oftentimes it can be relatively minor changes to be able to redirect some of those flows that actually have really significant outcomes. So I think, we look at this problem, it looks, overwhelming. But I think we were able to take advantage of some great work the township did to redirect some of the stormwater that was coming off of North Shore Road. And that really allowed the changes that we made then on Lake Drive to be very effective. And I'd say since we've implemented this, it's been about a year. We've really noticed a significant reduction in the amount of erosion that we're seeing on Lake Drive, the amount of surface runoff that we're seeing coming into the lake. So I think it was a great opportunity.
Awesome. Thanks, Tim. And from our modeling efforts, this project, it does have a fairly large drainage area. The road captures a lot of water from above the hill. So we estimated this would reduce phosphorus loading to the lake by 2.2 pounds annually, which is pretty significant. And then kind of to wrap up, our third residential site has yet to be completed. It's located on Silverdale Road, but we're hoping it'll be done later this month. It's hopefully scheduled to be completed within the next couple of weeks. Again, similar issues kind of that we've heard around the watershed. A lot of folks are experiencing high stormwater volumes from these steep slopes that just cause water to come in fast and hard during storms, which creates a lot of erosion and concerns for carrying sediment and pollutants into the lake. So again, these landowners have a drainage channel leading down from Route 63 with a culvert that's carrying a lot of stormwater. We're also proposing here to add a series of check dams down their drainage channel to help slow that stormwater and reduce the erosion that is coming down from that channel and across their property into the lake. They also have this small 4-inch culvert that crosses their driveway from that upper channel. And they're going to replace and enlarge that culvert to help allow the flow to go through the culvert. Now it's currently washing over the road and creating additional erosion that way. So we want to make sure the water's going through the pipe and through the drainage channel. We're going to add some riprap around the culvert outlet as well to help reduce erosion from the water coming through the pipe. So those are kind of the proposed changes coming there. At Silverdale Road, which will hopefully be completed in a few weeks. And then I don't have any additional photos, but as Jason mentioned, we had some extra funds available with the grant, and we're looking to replace a couple of extra pipes around the boat launch parking lot area, which are currently clogged and crushed and not quite functioning the way that they're supposed to. So by replacing those, it'll help promote proper drainage of those new bioretention systems and really help make sure everything's working and flushing properly as it should. So I think those are all the slides I have, but I'm happy to answer any questions folks might have about the current project, any of the practices that we've implemented.
Great, thank you, Mindy. You kind of mentioned at a couple points, if I might just jump in here to kick questions off, could you give a recap of the total phosphorus loading that we're looking at reducing through all of the projects? Do you have those figures available?
For just the current grant?
Well, if you have the ones for the last grant, you mentioned that briefly, didn't you? Maybe just all of them. That would be cool to see how we're faring. I know the total figure was like 42 pounds should be reduced, ideally.
Exactly, yes. So from the current grant, we're estimated that the projects that have already been completed should reduce the phosphorus loading by about 3.1 pounds. That's not including the last couple of projects that haven't yet been completed. We'll finish those calculations after the project's in the ground, and we make sure that, you know, the sizing and everything is the same as what we put in the plans. We want to make sure what goes in the ground is the same so that we can make sure our estimates are as accurate as possible. So that in combination with the 9.2 pounds from the first phase puts us at about 12.3 pounds, which puts us close to 30% of the goal, and we should get a little closer with those last couple of projects as well.
Vinny, I know those phosphorus calculations are estimates. When would we expect to see actual changes in measured phosphorus within the lake? What's the kind of the lag time before you start to see the impact of some of these changes we make?
That's a good question, and probably doesn't really have an easy answer. It's hard to know exactly how Spofford Lake is challenging. In particular, it has a really slow flushing rate, which is when kind of all the water flows out of the lake, kind of turning over new water. It's 5 years for Spofford Lake. So I think you guys might see changes a little slower than some other systems in the area because you have a longer legacy impact of that phosphorus flowing in from the past to be able to cycle through. So I don't have a direct answer to that, but it does take time. Environmental changes are unfortunately very slow to see the results of, but hopefully, you know, in the next few years, I know the Spofford Lake Association does a really great monitoring program every year. So hopefully they'll be able to see some good results soon.
And you also mentioned the role of internal loading on the lake. I don't know if you have an estimates of kind of the relative percentage of surface loading from phosphorus versus internal loading for Spofford.
Yeah, that's a great question. Let me see if I can pull that number really quickly because I don't have it off the top of my head other than the 50% from stormwater runoff. That was easily the highest level. There's also additional inputs from like septic systems, wildlife. There's a few different things. Okay, let's see. So we estimated that the internal load is actually only a 6% contribution to the total phosphorus load. Watershed is the biggest source. You guys actually have a large atmospheric deposition of phosphorus. 25% of the load comes from that, and then septic systems were estimated to be 15% and waterfowl 4% at the time of the watershed management plan. So internal loading is probably not likely to be a huge issue moving forward, but it is just something to be aware of. The low oxygen conditions at the bottom of the lake are concerning for other reasons, for like fish and other organisms that live in the lake, in addition to that internal phosphorus loading potential.
Might be taking a step back, but would you mind just explaining again how the different projects are selected for each grant? You know, how did the parking area and these specific residential properties get selected for this work?
Yeah, that's a great point. So some of our bigger road sites like the boat launch parking lot, those come from the watershed survey in the watershed management plan where we identified those 16 sites I mentioned of areas that had existing erosion or other stormwater concerns that needed to be addressed to hopefully help meet that phosphorus loading goal. The residential sites were more of a collaborative effort with the community. We kind of convened the partners on the project and asked about different areas around the lake that folks knew were experiencing erosion and stormwater issues. And what we tried to do for this phase of the project was get a couple projects from each of those problem areas that folks mentioned so that we could kind of spread the grant funds throughout the watershed and not concentrate too much in one area so that we could hopefully help a broader range of folks. So that's why we had a couple projects down in the southwestern corner of the lake and another up in the northeastern section to hopefully spread that help around the watershed. Some folks might be aware there's currently another study going on the Pinnacle Springs area of the watershed that's funded through a different grant. And that was another area brought to our attention of steep slopes, high stormwater volumes. Folks are experiencing a lot of erosion and flooding in that area. So we're looking, that's just a planning study, but we're looking at some engineering designs to help address some areas in that zone with the hope of hopefully, you know, applying for implementation funds down the road to address those sites and others.
Great. Well, I think you've given us a great overview, Mindy, of the work that's been completed and some of the work that's to come in the near future. If there are no other questions, Kelly, I'll happily turn it back to you.
Do we freeze up?
Uh-oh. I was just
Think we're
saying,
okay.
if there are no other questions, then I, will gladly have the recording to share with the rest of the Spofford Lake Association. And if you had any other additions, turn it back to you.
Great. Are there any other questions from anyone on topics for Mindy or Jason? Or Tim? No? Great. As Jason mentioned, we'll share the recording to the website. And as always, please reach out if you have any questions, and I can either help connect you with these individuals if you don't have their contact, or probably answer your questions as well. So thanks for being here and taking the time, and yeah, enjoy happy fall foliage.